Hello everyone, and thank you for joining us for today's webinar, Expertly Prepared Data Produces Better Models Faster. I'm Haley Matisow with RapidMiner, and I'll be your moderator for today's session. I'm joined today by Tom Ott, our RapidMiner marketing data scientist. Tom will get started in just a few minutes, but first a few quick housekeeping items for those on the line. Today's webinar is being recorded, and you will receive a link to the on-demand version via email within 1 to 2 business days. You're free to share that link with colleagues who are not able to attend today's live session. Second, if you have any trouble with audio or video today, your best bet is to try logging out and logging back in, which should resolve the issue in most cases. Finally, we'll have a question and answer session at the end of today's presentation. Please feel free to ask questions at any time via the questions panel on the right-hand side of your screen. We'll leave time at the end to get to everyone's questions. I'll now go ahead and pass it over to Tom.
Thank you very much, Haley. Good morning, everybody, and I'm glad to be here to talk to you about a problem that we as data scientists, data engineers, data analysts have to always deal with is messy data, right? What we want to do is we want to take this data and we want to make the data set more robust to build more accurate models and so forth. So give me a second here and I will now go into today's agenda. So there are always challenges with data dirty. We're always going to run into this. They say something along the line of 60 to 80% of the time we're going to be dealing with data cleansing, replacing missing values, maybe imputing values, changing string values, and doing a whole host of other different things like feature generation and measuring or detecting outliers. So this is what we're going to have to do. And with RapidMiner, we always call ourselves an advanced analytics platforms because we have some really great algorithms under the hood. We can model, we can validate, we can test them, but we also have a very, very rich data prep set of tools available, mostly going from data exploration, where we first look at the data, to data blending and data cleansing. And all those different things are operators that we have stock with RapidMiner. When you download RapidMiner Studio, they all come with it right off the bat. And the reason why we have them is because some algorithms require the data to be transformed in such a way that it can read it and it can make sense of it. For example, a k-nearest neighbor algorithm can handle missing values. But if you want to use, say, a support vector machine algorithm, it would blow up right away once you load data in with missing values. Other algorithms can only handle certain data types. Maybe to go back to support vector machine, they can only handle numerical input types. So if you have maybe some string values in your data, maybe like male, female, you might have to convert them to zeros and ones to be able to use that algorithm. Okay, so we're going to really focus on the first part of this time to value data flow, right? Data prep, models and validate, and operationalize. We're going to start at the beginning. We're going to start right here at the data prep because, as I said before, to have really robust models, to have really accurate models, you need to really spend time on the data quality aspect side of your training data. To build awesome models, you need that awesome training data set. And quite honestly, I do spend all my time pretty much right here. At RapidMiner, we joke and say, well, you know, they say outside that 60 to 80% of the time, their time is spent building data sets, and then the rest of the time is building and coding all the algorithms. RapidMiner, it's 90% of the time is data prep because the modeling, the evaluation is so quick because of our reusable visual programming blocks called operators. Right? I touched a little bit upon this before, just in my introduction, that the data in the real world is dirty. It's incomplete. You could have a column for occupation, and 90% of the column is filled with everybody's occupation in your data set, and the other 10% is missing. How do you handle that? You could have bad data. If you have an age column, somebody could have entered 222. Reality is that we don't have anybody age 222. It is maybe we were using a random. Yes.
Looks like we lost you for just one quick second, if you don't mind repeating what you had just said.
Sure, sure. So in the real world, data is dirty. We sometimes have incomplete data, missing values in our data set. And sometimes it's incredibly noisy, meaning that perhaps somebody put the wrong age into an age column, or maybe there was a negative, or maybe the age doesn't really fit in our scheme of things. Maybe the minimum age for our workforce is 16 and somebody put in 10. Also, in some cases it's inconsistent. We may have been using a rating scale from 1 to 3 or 1 to 5, and somebody changed it to A, B, C, and D. Okay. How do you handle that type of data? How do you transform that? And how do you make this reusable? Because ultimately, we may be doing this data prep work to feed something downstream. It may not be modeling. Okay? It may not be modeling. It may be to a dashboard, a BI cube, like Tableau or ClickSense. How do you build processes that create these catch-all systems so that if some dirty data does slip through, how do you fix it on the fly, and how do you prevent your downstream systems from breaking? So right, we have to deal with missing values, we have to correct those values, we have to generate new features, we have to find outliers, right? We need to do all that with RapidMiner, and you can. Okay? Ultimately, as I said before, bad data quality, garbage in, garbage out. We all know this. This is pretty straightforward. So we know how serious this type of situation is. With that, I'm going to switch it over to my demo in a second. But I want to just highlight a couple things that I'm going to go through in this demo. Is we begin at the beginning. We begin with data exploration. The first thing we do is we use RapidMiner to visualize our data, to read the statistics, to understand what we have, so that we can maybe generate some questions. Perhaps you received your data dumped from a database administrator, maybe in a spreadsheet, and you start exploring it, and you realize that, oh my God, there's a lot of missing data. Did he or she give you the right data dump? Okay, maybe they did. If so, then you have to come up with a strategy on how to replace those missing values. Other things like data blending. You may then work on replacing your missing values, and then maybe you want to generate a new feature. Maybe you want to extract the date where somebody joined your company and the date where they left and calculate the elapsed time. We could do that in RapidMiner. Generate new features. Likewise, we could normalize. We could detect outliers. Maybe there was some bad data entry and it does not seem to fit with everything else. What are those outliers? All those three sets, exploration, blending, and cleansing, are all done within RapidMiner Studio in a one platform way. Okay. Now, let's switch over to RapidMiner. Give me a second here while I pull it up. Okay. For those of you who are new to RapidMiner and you first load it up, you should see this type of development interface. We have our repositories over here. I'll just touch on these briefly. This is where you save your processes, local data stores, where you make database connections and so forth, and where you can get your data and build your workflows. Down here, which we're going to talk about right now, are our operators. And these are these visual programming blocks, these operators that you chain together to create a process that can be reusable, it can be operationalized, you can cleanse your data, blend your data, and it can also model your data and get you to your results. So we're going to focus on these two directories right here, blending and cleansing. You can see right over here, blending has 77 operators. There's that number, 77. And cleansing has 26. So if I were to come over here and expand this, you'll see that it's subfolders. There are 4 subfolders here. One about attributes, one about examples, table, and values. I'm going to pause here for a moment, and I'm going to talk a little bit about RapidMiner's nomenclature. What normally people call columns in a data set, we call in RapidMiner attributes. Okay. What people call rows in a data set, we typically call them examples. So when you want to, say, filter rows, you would actually use a filter example operator, filter examples. Okay. If you want to select columns, you would then use a select attribute operator. So this is something handy to understand right off the bat. If you're brand new to RapidMiner, you just downloaded and you're wondering, what the heck is an example? What the heck is an attribute? That's what those things mean. Okay. Let's just go back here and take a look at what we got. Okay. Under blending, blending is really about how you blend together different attributes or how you actually blend together data sets. Like we have these fantastic data joins, similar to SQL joins, but done in a visual way, like joining, appending, and so forth. Things like grouping, aggregating your data, all important things that you need to do maybe to slice and dice and prepare your data. To things like, as I mentioned before, filtering your data, sampling your data. You might want to sample a percentage of your data, or you might want to bootstrap or even balance your data. You could do that here as well too. And then as we continue through the blending, we move to cleansing. And these are some of my favorite operators. These are where we come up with strategies on how to replace using values. How do you replace integers? Okay. How do you replace nominal values or string values? What about taking care of duplicates or binning? All these different operators are all here to prep your data and prepare them in a way so that your model can be run quickly and easily. Okay. Now, that said, we're going to start with a data set, a customer churn data set. This is a data set that we use in RapidMiner for some training. And I'll make all these processes and this data set available to download later on after the webinar. And this data set is something that we typically will see. Maybe your database administrator gave you this dump, and it looks something like this. We'll drag it into the canvas, we'll wire it out, and we're going to start with the data exploration. Okay, very important. Come over here and we hit run, and when you execute this process, RapidMiner will create a results view. This is the first thing that you see. There are, in this case, 1,000 rows, and I can scroll down through here, scroll all the way to the end, and I can see that I have 1,000 rows. And also over here, up on the top, RapidMiner will say, hey, you have 1,000 examples. There's that word again, examples, okay, for rows. And it says you have 8 regular attributes. There's that word attributes again, for columns. Okay. Now, this data set's very small. Okay. I mean, I could actually sit here and look through it. I see question marks. I could see ages, row numbers. I see all these different items in here, and I could probably scan through these pretty easily. But the reality is that we deal with probably millions of rows of data, several thousand columns or attributes. So it gets very hard to really eyeball this data and look it over. So how do we actually try to make more sense of it? If you're an R user or a Python user, we're familiar with the head command or the summary command, which will give you a high-level overview of your data. We have that here as well. We have that as a visual way, a visual tab to do it in. And that's the statistics tab. Okay, let's click on that over here. Now I get a higher-level overview of the data. I actually have the column name. I have the data type. We'll talk about that in a second. And we have missing columns or missing values, and something called statistics. Okay. Now, in RapidMiner, we have different data types, which also need a little bit of explaining. The integer is self-explanatory. We know what integers are. We know what real numbers are. But we have something called polynomial or nominal value types. Those are actually string values. When you see a binominal value type, and that means it's either 1 or 2, it's 2 strings, like male, female, yes, no. If you see something called polynomial, it means that the values have multiple strings. They could be, in this case, like here, payment method. Over here, click on this. You'll see that if I click on details here, you'll see that I have 3 nominal values, credit card, cash, and check. And that means they're polynomials, more than 2 or multiple. And what I also did here, too, is part of this data exploration part that I'm talking about. How do I actually start looking at this data at a high level, in a high-level way? You can see here, I already did this. I clicked on this payment method. I got this little chart here. It's a little bar chart. And I also see, if I pull this out of the way, I see something called least, most. So I could see that the least entry are check, the most entry or credit card. And if I click on details over here, I get another window. I get a pop-up here. I could see what fraction of the data set each one of those entries are and what the absolute count is. Okay. Very, very important. Very, very handy. Let's close this for a second. Now here's another neat thing here. This is just a little visual clue, a really quick way to inspect your data. But there's a link here called OpenChart. Okay, OpenChart will take you to another visualization part, workbench of RapidMiner, which is the charting function. I can either click on Charts here, or I can just click on OpenChart here. Once I do that, I'm now presented with RapidMiner's visualization workbench. Okay. I'm going to make a distinction here. This is not Tableau or Click or some other BI tool. This is for the data engineer, the data scientist, the data analyst to explore and start working with their data. Okay. You can see here we have some bar charts. We can see how many entries of the credit cards and check and cash. I can quickly see that credit card tends to be the predominant way to pay for whatever this product that we're selling. I can see over here in my chart style, if I pull this down, I can also visualize the data in different ways. Scatter charts, okay, series charts, histograms. I can even make pie charts. So not every data type or not every data set will lend itself to visualize, say, maybe as a time series, unless it's time series, or a scatter chart, but there's multiple different ways to look at it. So you can explore over here. And what I will say, I'll make a quick little say here, is that you can actually build your own custom charts by using the Advanced Charts tab. We're not going to go into that today here, but this is just something for our viewers to remember. You can actually drag and drop and build your own charts. You can relabel the chart title. You can change line types from line to dots to different things like that. So this is also available to you. And there's also on our docs.rapidminer.com website a PDF you can download. You can see how all this works. So there's also something to think about. Okay, let's just go back to our data set here, actually our statistics data set. Okay, let's take a look at what we got here. So we just looked at payment method, fine, but I'm looking at over here. I'm looking at my age. I have one missing age value, and if I click on this over here, I'll see that, oh, okay, this is roughly my histogram distribution. I see that I have a minimum age of 2. Okay, that doesn't make sense. And I have a maximum age of 234. Okay, that doesn't make sense. Okay. Let's look at gender over here. Now, normally I should have only male and female, but I have the German word for female here. I click on this. Let's take a look at it. Oh, I see we also have, if I come back over to details, some other entries. So I see here that I have male, female, which is what I want, and 5% of the data set somebody entered männlich, which is male in German, and somebody entered weiblich, which is female in German, about close to 5% of the data set. So I have to do some transformations here. I have to remap, or I have to replace männlich and weiblich with the word male and female appropriately. Okay. All right, good. What else we can take a look at over here? I also have another data type called date time. Okay. In RapidMiner, when you import a date, 90% of the time, RapidMiner is smart enough to recognize, oh, this is a date. It's a date format. It'll automatically create a special data type which will allow you to do date differencing calculations using dates, all based on the epoch or something relative to weeks or months or something like this. So for those who do not understand what the epoch is, this is a time in computer science, I think it's January 1st, 1970, where a computer programmer said this is the reference point, and from there you can calculate the elapsed milliseconds to, say, today's date, November 24th here in this example, 2009. So you can do a lot of different date calculations over here. Let's take a look at this one over here, churn date. Okay, 497 values are missing here. Okay, let's think about this. So if I look at my data set, come back to my data set here, we sell some sort of product, and this is a churn use case. So we want to understand and build a model to try to predict churn. So if I have here 2 columns, last transaction date, that's the last time the customer interacted with my website or my company, and I have a date here for churn. So obviously we know that if we have a date that they left, so we know they've churned. The missing ones are people who have not churned. They're loyal. So what I'd like to do is as I prepare my data, I want to generate a new feature. I want to generate a new feature, create a new column called churn date, and make a label for have they churned or are they loyal. And I'm going to use that and feed that into my model later on. If we get to it, we'll build a very quick model. You can see how you can do all this. Okay. Now, let's get started. Let's build our first process. Go back to design. And I'm going to open this up because I've already created. We're going to replace the values. First thing we're going to do is we're going to replace the männlich word with male, and we're going to replace the word weiblich with female. And what I've done is I've dragged in my customer data. Let's just do a breakpoint here. Let's make sure it's the same. Okay. See, okay, we got 1,000 rows. Excellent. All right, look, everything looks similar. Let's go back to design. And I have two operators called replace. Now, let's go see where those replace operators are. If I come in here and I search, I do a replace, I could see that they're under the blending directory, under values. Okay. In RapidMiner, each cell holds a value. So here we're going to replace some value, whatever it is. Okay. And the replace operators are actually very, very powerful. What they do is they have a way to filter. I can either say, hey, I want to search everywhere in the data set, or I want to search specifically in one column, in which case we're going to select the gender column. And what I want to do is I want to replace everything with the word W. Okay, here I wrote a regular expression. They're very powerful. You can actually type in the word. I think it's weiblich, something like that, and replace it by female. Oops, if I misspelled it correctly. But sometimes you need to have better selection criteria. So this can handle anything you put into it, and it's also regular expression friendly. So for me, this is a very powerful operator. All I did was select anything that begins with W and replace it with female. Likewise, I did the same thing for the male one. Come down over here and I can select do it all. So in this case, anything that starts with the letter M throughout my entire data set will be replaced with male, and I might not want to do that. So I'll come over here and I select a single column or single attribute, right? There's that word again, attribute, column, attribute, and I select the column, gender. Okay. So before I run this process, let's just take a look at what the data looked like before, right? We had here the gender column. Let's visit our statistics just to make sure that we have 4 different values, right? Male, female, männlich, weiblich. And when we run this process, it should only present us with male and female. Let's close this. Go back to design. And I'm going to run it because it's paused right now. Right here, it's paused. Let's run it. And it'll process it. And now it'll present me with a new data set. Let's go back to statistics and verify this. Come back to gender. Aha! Now we have 550 counts of male and 449 counts of female. So we did a nominal conversion. We took a string value called weiblich or männlich and mapped them or replaced them to the proper meaning or the proper value, which is male and female. Excellent. Good first step. Let's talk about doing some more cleansing. Let's actually talk about gender. You see here I have one missing value of gender. In my customer data set, replacing missing values, there's a whole art and a science in my mind to dealing with missing values. Sometimes you need to actually come up with a good strategy. If maybe a percentage of your data set, a small percentage, maybe less than 5% or so are missing, you might want to delete them. You might want to filter them out. In some cases, you might not want to do that. In some cases, you might want to replace them actually with an average value or a minimum value or a tag word called missing or not applicable or something like that. It's really going to depend on your domain. It's going to really depend upon your industry. Like for instance, if I looked at the age, I have one missing age. Maybe I want to replace it with the average age or maybe a minimum. Maybe I know that all my workers start at age 16 and there's no way that they're going to be starting at the age 2. Or if I don't know it, since it's only one, maybe I'd filter it out. I don't know. So what we're going to do now is we're going to talk about talk about filtering out the missing value of gender. I'm going to open up the next process here. I'm going to build, just so you know, I'm going to build on this process here. I'm going to build it into one long process that does everything. Okay. Now, okay, so looks familiar. My customer data, replacing my male and replacing my whiteley. And now I have a new operator called filter examples. And just so you know, right, and we showed it before in the beginning, type in the word filter or examples. You'll see here it's under blending, under examples, and under filtering, right? Once again, that word examples for rows. So we're going to now filter out the row that's missing for gender. Another powerful operator. I love this operator. I especially love the custom filters. Once you drag and drop this in and connect the wires, you'll see that you have a custom filter class, condition class. And there's other different ways, really simple ways you can just filter out no missing attributes, which are columns, or no missing labels and so forth. We're not going to talk about these today, but they're there and available for you. We're going to look at custom filters. And if I click on Add Filter here, custom filters gives you like a wizard. Really, really cool. It allows you to add multiple rows. You can select, payment method. You can select age. You can do different things like that. And you can do all these different types of filtering automatically. Now, you'll see here that age comes up with an equal sign, but payment method is equals. Hash code is equals. Well, when this thing is toggled on, pre-select comparators, RapidMiner, based on your data type, if it's a number, it'll give you a comparator that's related to numbers, like greater than, equal, not equal, so forth. If it's something that's a nominal value, like male or female, or payment method, which is credit card, check, cash, it'll give you a comparator that's related to nominal, to strings. So like, does it equal that? Does it contain it? Does it start with, end with, and so forth? You can, of course, override all this by just toggling this off, and then you should be presented with all the options here. So just so you know, that's a handy thing, that if you see that this pops up and it's not the right comparator, you can just toggle this off and do that. RapidMiner is pretty smart. It propagates the metadata and it makes some assumptions, but sometimes the assumptions are not 100% correct, so you have that flexibility and that ability to override that as you may need. Here what we're going to do is let's get rid of these guys here because we're just focusing on gender. One other thing here, this match all, match any, this is really your and your or. So you can match gender and age specifically, or gender or age, or something along the line. So you can toggle between these. These are really, really handy to do. So let's hit OK. I'm going to come over here, and I'm going to put a breakpoint here. This stops the process right as we did the replacement. And now, we see here we have 1,000 examples. I'm going to filter out that one missing example. So when I filter out that example, I should have only 999 examples. Run it again. And now, here we go. Now I have 999 examples. Go to my statistics page, double check that I don't have a missing gender. Here we go. 0 missing genders. Awesome. Awesome. We're getting closer. We're getting closer to what we need to do here. Next thing I'm going to do is I'm going to actually filter out my age. And I want to normalize the age because I want to start prepping it. I'm thinking of modeling, maybe put into a k-nearest neighbor, something along that line. So let's open up the next process here. And you'll see, I'll keep building on the same process here.
Tom, it looks like we lost you for just a second there as well. Sorry.
Okay. Okay, so I open up my process, my new one, where I'm going to filter the age and normalize the age. This process looks like what we saw before. I have my replace, filter, and now I'm going to filter age. Here's what I'm going to do. If I go back to my add filters, I actually have 2 entries, age and age, greater than 16 and less or equal to 100. And I want to match these. So this is an AND function. So filter out and give me only the data that matches age greater than or equal to 16 and age less or equal to 100. Okay. And finally, at the very end, take age and normalize it. You see over here, once again, I dragged the normalize operator just so you know where the normalize operator is. Normalize is under cleansing and under normalization. So you could drag that in there. You could normalize, denormalize, scale by weights, many, many different ways on how to handle your data there. So if I drag this in and I connect the wires, I'm presented here in my parameter window with a way to filter the columns, okay? Attributes. Right? Attributes are columns. Here I build a subset. As opposed to single, I build a subset. So I click on select attributes, and I can then do a couple things. I can select which ones I want, which is also handy. In this case, I'm only selecting age. I could do something like this. I can drag and drop, push these over, and do another cool way of just selecting what I need and when I need it. Okay? And what I'm going to do over here is I have multiple methods, range transformation from 0 to 1, proportion transformation, but we will default with Z transformation. In this case, a very popular normalization technique to remove your means or to make zero means, so to speak. Okay. So let's go put a breakpoint here. Make sure we filter out the ages. Actually, we'll stop right before. So we'll inspect the data here. Make sure that the age is still 2 and 234. Take a look. Go back to statistics. Look at age. Aha. I have age 2 and age 234. And hopefully when I'm done, I should have 16 to 100. So let's go back and to design. It's going to now stop here when I press play. Okay. Let's go back and inspect it. Aha, you can see we went from 999 down to 996. Okay, so it definitely did do a filtering here. Let's look at the age. Oh, I see. It also now gives me from age 17, so there must have been nothing that's 16 and nothing that's 100, but 99. So now my age range is 17 to 99. And you see that it also filtered out the missing one. Okay? Because the missing one was missing. It did not meet any of the criteria for greater than 16, greater or equal to 16, or less or equal than 100. So that's gone as well too. Okay, so the age is beginning to look pretty good. If I wanted to, I can now explore it better, and I can see, from my histogram over here, a lot of youngish type of people, some people in their mid-40s to 50s, and then we trail off even to some people over here that are in the 80s and 90s. So those are probably great-grandmas and great-grandpas that are loving technology. Let's go back to design. The last step now is to normalize the age. We hit run. And there we have it. Now our age is completely normalized. Let's go to statistics. We could take a look at it now. Click on here, and we could see that we have a minimum and a maximum, 0 average, and 1 standard deviation. Exactly what the Z transformation should be doing. Perfect. All right. Now let's build on top of this process. What I'm going to share with you next, actually, is, and don't get scared, is we're going to start doing some housekeeping things, right? I mean, as we start adding these operators, it can get messy. So what we're going to do is we're going to take these operators here, and we're going to put them into a sub-process. Because we want you to think that when you're using RapidMiner, you start at the beginning, right, with exploration, cleansing, and so forth for data prep. We also want you to think about the end in mind. For those who are Franklin Covey fans, begin with the end in mind. So we want you to start thinking about how you're going to operationalize, how you're going to create processes that are easy for your colleagues to use or somebody to pick up if you were to leave your firm, or somebody needs to do some troubleshooting. We want you to start thinking about how you're going to logically organize all these wonderful operators, all these wonderful visual programming blocks here into something that can be easily understood and make sense for you. Okay. So now what we're going to do is we're going to open up the next process. And you see here, the 2 filters and the 2 replaces are gone. You don't see them visually here, but they're here. They're in a new operator called subprocess. And subprocesses are just ways for you to group different operators. They're ways for you to make sense of things, and you can come here and you can create a tag by creating a note. You can say something like this subprocess is for replacement and filtering. Okay, filtering. Get rid of this, delete this here. And I take it and drag it onto here. You can create a note, so forth. And then if I double click on this, because it's a subprocess, this little tag here means that there's something going on underneath the hood. You can see here, there's my replace, my two replaces, my two filters, and so forth. So a really great way to start creating a little subprocess or little building blocks that you can reuse over and over again. And even though we're not going to talk about building blocks in this webinar, go check out the post I wrote about building blocks on our RapidMiner blog. Always go to our blog. There's some really great stuff there. Building blocks are really handy, fast ways to insert bits of processes or bits of subprocesses that you use over and over again. And I'll just digress here for a second. I have a bunch of building blocks that I use over and over again. You can see that I love to use influence factors. I love to read S&P 500 data. I love to do different transformations that I personally use to make my daily work faster. Okay? So you can also just create a building block. You just click on this, and then you can save it as a building block, and it'll become available to you. Just digress. Okay? So once again, here's our subprocess that does the filtering and replacing. I normalize. And now what I'm going to do is I'm introducing two new operators, generate attributes and select attributes. Okay. Go back to the beginning. Attributes are columns. So generate attributes means you're going to generate new columns. We want to take this data, so I'll put a breakpoint here. I'm going to do a few things to this data. We're going to create a new column, a new attribute that will say loyal or churn based on this information. And what we're going to do is also we're going to modify the postal code here. We're going to extract the first digit because then we're going to feed that into a model later on. We're going to just extract the first digit because that's important. In Germany, I believe these are German postal codes. Depending on what your first digit is, depends what region of the country you're located in. So in this churn data process, we want to maybe see if there's any type of statistical significance to the location of where they're at. Okay. So let's come over here back to design, and let's investigate this generate attributes operator. Before I do, generate attributes is located under your blending directory, under attributes, under generation, right here. Another one of my favorite operators. I use this one all the time. I call this the Swiss Army knife of RapidMiner. You can do in-process calculations, you can convert, you can take replace nominal values, you can do dates calculations, you can do so much with this operator. It's amazing. And let's dive into it now. I highlighted over here. You'll see my parameter window. All I'm left with is something called function descriptions. If I click on this, it says edit list. I can come in here and I can create my new attributes, my new columns. I'm going to create one called column label, and I'm going to, in this case, overwrite the postal code one. If you name an attribute in here with the same name of an existing attribute, it'll overwrite it. This comes in handy. Sometimes you don't want to generate hundreds of new columns. You just want to just do a transformation and keep the same name. Just change it. Okay? Let's take a look at the first one here, churn label. Here's my function expression. Okay? It appears to have an if-then type of statement. If missing churn date, then loyal, else churn. Okay. What happens if you don't know how to write this expression? Where do you get any clues from that? How do you learn to write expressions in here? Well, you click on the calculator here. And this will take you into the function expression writer. This has been revamped in version 6 point something, and this is a fantastic new way on writing expressions and doing in-process calculations. I love this one. You can see here that you have functions like logical functions, the if-then one, which we're showing here, ands, ors, you can compare, missing data, equal data. You can even transform text, cutting, starting, matching, finding, generating the length of them, indexing them. You can then replace, concatenate. You can make lower, uppercase, prefixes, all these different things, trimming data, to things like mathematical functions, like square roots, natural logs, IDs and logs and so forth, statistical functions, average, max, mins, random numbers, trig functions. I mean, it goes on and on. I would highly recommend all of you spend some time to go and dig through this one. It's really, really fantastic. And the ones that I use quite a bit are date calculations. Here you can once the data type is date time, you can do calculations of the time before, or add dates, or do date differencing. All great things. And here's a neat thing. All these inputs, they're right here. Here's my regular attributes. These are all my data set. RapidMiner extracted the metadata and put it right here for you. And you can use basic constants. You can use true, false, pi, infinity, so forth. You can even use something, this is advanced functions called macros, which is also part of a, I believe, a webinar that was done for us, RapidMiner, a little while ago about using loops and using advanced ETL functions, advanced data prep functions. There's so much more that you can do with this, which is fantastic. Let's take a look at this. Here what I'm using is an if-then statement. I'm using missing. I'm saying if the churn date, which is this guy right here, right, is missing, then the person is loyal, else he churned. Okay, my function is done. And you'll see here that if you wrote your function correctly, it'll say, hey, your expression is syntactically correct. If it's not, you'll see a little red error here, and it'll tell you what's going on. Okay, cancel out of this one. Last but not least here, the postal code. Let's click on this. And here what I'm doing is the postal code, if I come to my regular attributes, it'll give you a clue. Postal code, you see this little hash sign? That's indicative of a number, an integer. In this case, it's an integer. But it's saying that, hey, this is a numeric type. So I can't extract the number unless I turn it into a string, and I'm using the prefix. So here what I can do is I say, using the str command, str, which stands for string, right here, a conversion. I can convert a numeric number into a string. Then use the prefix command, and then extract the first digit, or the first string value, which in this case will be the first digit. And while I do that, overwrite that column, and we're good to go. So let's take a look at this. So we stop the normalize here. Let's put a breakpoint here. And now let's just see the conversions. Now I've generated a new feature called churn label. Let's see here, loyal, so forth. Churn, loyal, so forth. Right here, this is missing, so this person is loyal. And I took the postal code that originally had multiple 5-digit numbers and now extracted only the number here. All right, great. Good. What's the last operator here? Select attributes. Okay. I'm getting close to getting ready to model this. So let's just take a look at the data real quick. Let's look at statistics again. I have 0 missing, but I have these guys here that are missing, but I did a conversion for churn label. So what I want to do now is I want to select the columns I want to pass into my model. I want to take age, I want to take gender, I want to take payment method, I want to take my churn label, my postal code, and maybe my last transaction. There might be some sort of analysis or some sort of statistical significance on whether or not it was the last time they interacted with my website. But I don't want to take hash code. I don't want to take row number. I don't really need churn data anymore because I made my feature generation. I generated a new feature here. So I want to be able to select those out. I want to clip them out. I want to delete them, or I want to remove them. Just so you know, RapidMiner does not delete your data unless you specifically say you want to. Okay? As you build this process, RapidMiner creates metadata views. Okay? So the data is not destroyed. It just gets modified and a new view is created. So even if I use this select attribute operator, which in this case is selecting the columns, the resulting data set that gets wired out is a new view. What you see here, see this little nub? That's original. So the original data is still here. If you want to output it, you can. It'll keep it all there. Okay. Let's toggle this one on. Here, I'm going to do a subset, select the attributes. I take age, churn label, gender, so on and so forth. Hit apply, and then hit run. And now my data is almost ready to be modeled. I'm going to do a few other things to it. I'm going to calculate outliers, and I'm going to convert this date into a number, into elapsed milliseconds. So let's go back to design. Let's open this next process. Okay. First thing we're going to do is we're going to convert the date. And here, RapidMiner has, these are also going to become your favorite operators. Under blending, attributes, types. This is where you convert numericals to nominals, right? Numbers to strings, strings to numbers. This is where you convert your date to numbers, or convert a nominal date, like say, month, day, year, to year, month, day. Sometimes the Europeans, they go with year, month, date, and the Americans like to go month, day, year. So you might want to do some conversions. All these are located right here, and they're going to become part of your best friends, especially parsing numbers, formatting numbers, even re-guessing the data types. Maybe somewhere along the line you did some major conversions and you might want to convert things back into integers or back into nominal values or something like that. So these are also very, very powerful tools to use right here. So all we're going to do here is we're going to select the last transaction. We're going to convert it to a millisecond relative to that epoch, January 1st, 1970. So let's come over here, hit run. And lo and behold, based on last transaction, now we have the elapsed milliseconds from the epoch. So we've converted that date, whether it was November 24th, 2009, now to how many seconds have elapsed since that was recorded. Awesome. Okay. So we did that conversion. Now let's calculate outliers. Okay. And what you see here, I've also started doing more housekeeping. Right? Originally we had a sub-process over here where I click on, you'll see the replace and the filters. Now I created another one for the normalization. The normalization, the feature generation, the selection, and the conversion here. It's just something to keep my process looking neat and tidy and something that I can use over and over again. Now I come and drag a detect outlier operator. I do a search for detect, or if I do a search for outlier, let's do outlier. RapidMiner comes with 4 stock outlier detection operators. Very handy, very good. They use different ways to detect outliers, from Euclidean distances to densities to the local outlier factor and so forth. But I also want to bring your attention to a really fantastic anomaly detection suite that's available on our extension marketplace. In that extension, they have many, many more, about 15 more different types of anomaly detection methods, going from most nearest neighbor to more anomaly detection scores to clustering and measuring the performances and so forth. So if you do a lot of outlier detection, I highly recommend you go to our marketplace and you download this extension. Over here, let's toggle this one. We're going to leave the default values. The distance function is Euclidean. We're going to run this process. And what it will do is it uses the local outlier factor score system. So it's going to generate a number. The more closer or less the row or the example is to 1, the less of an outlier it is. Tends to be, and as the number increases, the more of an outlier it tends to be. So over here, it automatically created an outlier column, and I can sort it over here. I can go, okay, click sort, and I can see, 3.276 is the highest. Or I can come to my statistics, and I can review this as well, and I can see the minimum and the maximum and the average and so forth. So also very handy. And we're going to now take all this data, and we're going to now put it into a process, to the model. The last process I'm going to share with you today before we open it up to questions is what all this data processing looks like. Over here, this is the data prep. Right here, this is all data prep right here. And these guys are the actual modeling part. Come over here, actually delete this here, and say this is modeling. And if I were to expand all of my operators, take them out of sub-processes, you can kind of see that, right? RapidMiner, 90% of the time is all data prep, and here's just your modeling. So if we run this process now, it's going to go to do all the work that we just did on this data set, and it's now going to go and build a k-nearest neighbor model, which we can evaluate. In this case, it's not going to be so good, roughly 60% for my recalls, and class precision, overall accuracy is 59%. Not good. Now I can come back, double-click on my cross-validation, and I can add my gradient boosted trees if I wanted to, and quickly remodel the data and get to my what's the word for it, to my confusion matrix quicker. While this is going, I'm now going to hand it back over to Haley for any questions.
Great, thanks, Tom. So as a reminder to our audience, we're going to be sending a recording of today's presentation within the next few business days. And like Tom said, feel free to go ahead and put your questions into the questions panel right now. It looks like we already have a few questions here right now. So I'll go ahead and ask the first question that I see. Tom, this person says, I've downloaded the anomaly detection extension from your marketplace. Are those LOF operators different than yours?
No, the LOF algorithm is the same. One of the things about the anomaly detection suite, which I like a lot, is that they've actually done some very good optimization. So they actually run a little bit faster than our native operators, but it's the same type of algorithm, the same math behind it all.
Great. I have another question here. At the end of your demo, you show one cross-validation operator. Is there a way to automatically iterate that over multiple algorithms?
Yes. So what I just showed you was probably the less elegant way of trying different algorithms, like over here, where I just copy and pasted and turned one on and turned one off. What I normally do in a production sense is we may have something called like a multiply operator, which will make multiple, so you'll do all your data processing up here, and at the very end you create a copy of the pre-processed data, and then what you can do is you can have multiple cross-validation operators, to do something like this, and then evaluate embed different algorithms in there. Of course, more advanced stuff is we have things called select sub-process, so you can do even more elegant solutions by doing auto modeling. I guess there's a lot of talk about auto modeling nowadays, or being able to just dump data into something and then auto model stuff and see which is the best model. We've been doing this for many years before all the latest interest in it. So yes, you could do it many different ways.
Great. Someone here is asking, how do you apply a decision tree to this?
How do I deploy a decision tree? Very, very simple. So let's just see here. Let's delete these guys. What I would do is I would maybe just, in this case, let's get rid of this and put a decision tree. Just look for the algorithm decision tree. I can find it. Drag it in. I think this will work. Yeah. I think the data types are good. And then just run the model. And what I could do is I can actually output the decision tree as well by outputting the model and outputting the performance. So while this is running, and we can investigate how good the model is. Let's see here. The performance tells me in a second. It's pretty good at predicting oil, not so good at churned, and the tree, in this case, splits on last transaction as being the most important one. So you can see here that if you went to go back calculate this, which you can, you could see what was the last date of interaction, which should tell you who's churned and who's loyal. Very simple to do.
Great, thanks. This person is asking, are there any common building blocks you or other RapidMiner folks have created that are available for download?
Oh yes, yes. Building blocks are actually quite simple. Once you can actually share them, they're very easy to share. We actually created a community board. If you go to community.rapidminer.com, also your best friend. I mean, it is chock full of all kinds of good stuff. There's a specific, if you come to RapidMiner Products Help, there's a specific subforum called Building Blocks where RapidMiner users can actually share and put their building blocks in there. There's some fantastic high-level stuff, some simple stuff. Like you see here, cross-validation using Python models. You can create a Python model and use it in RapidMiner to generating, optimizing decision trees and support vector machines. So all kinds of stuff in there. We encourage all of our users who actually build a cool building block to share it with the community, because the more you do, the better it becomes.
Great. I have another question here. How do you include Python code to create a data set?
Oh, very, very simple. So a couple things with Python where you're going to need to have pandas installed. So if you're running Windows, pandas can only come with, I think, the Anaconda distribution. But if you're running Linux or something, or even I think Apple, you could install pandas separately. So the way you would do that is you would just use our execute Python operator. We have and you would then, in this case, it would work, but you would then wire out the data into here. Click on Edit Text, and you would write whatever Python code that you need to do some transformation or whatever it is, and then you can pipe it back out into RapidMiner. If you want to learn more about that, just right-click on this and go Show Operator Info, and then down in the bottom here, we have some tutorial processes which you can, let's say, for instance, here, clustering, which you can then inspect the data. So here I'm taking RapidMiner data, pumping it in, and I have some Python code right here to do some work, and then it pumps it back out. So yeah, you can do that. Yeah.
Great. This person's asking, is there any way to use a seed number library to bring input data in?
Seed libraries? So yeah, we have actually a lot of the libraries. I believe you can do that. What you would do is you would probably use the execute program operator. So the execute program operator allows you to either execute a program to do something, or you could actually, if you want to use a specific jar for seed libraries, you can actually use maybe the execute script operator, which is a little bit of Groovy script. You can actually pull that into your process. So RapidMiner is Java-based, so if you're good at Groovy and good at Java, I mean, it'll work really well with you. You can do a lot with it with these two operators.
Great. So next question. This person is asking, I know you mentioned your blog post earlier, will there be a similar webinar on text data?
On like text mining, I'm pretty sure we will have one in the future. I have not been tasked to do that, but with text data, I mean, RapidMiner also shines very well on that. I do a lot of sentiment analysis, especially around Twitter data. So there are a couple of videos on our YouTube channel which talks about text mining Federal Reserve meeting minutes, doing some Twitter stuff, so you can check those out as well too. That's another resource, the RapidMiner YouTube page. Yeah, check that out.
Great. And then someone asked about the recorded version. Like I said, we'll definitely be sending that out within 1 to 2 business days. And then they're also asking, is there any reading material that you can suggest to follow up on this webinar?
So yes, there is the one book. There's 2 books I really like. One is Exploring Data with RapidMiner, written by Andrew Chisholm. I believe that's available to purchase off of Amazon. And there's also the book written by one of our partners, Semaphore. Really great review of all the features of RapidMiner and especially data prep. I believe, Haley, we may be doing we have occasional contests where we give the book away for free. So what I would do is I would probably try to reach out to somebody in our marketing group to see if we can get you a free copy or something like
that. Okay, thanks, Tom. So it looks like we're just about at the top of the hour. So for those of you who we weren't able to address your questions, we'll make sure to follow up with you via email. So thanks again, Tom, for your presentation, and thank you everyone for joining us for today's presentation. Have a great day, everyone.
Thank you. Bye-bye now.